In this video, I'm going to show you how to express a set in interval notation. And here I have some sets that are in set builder notation. And set builder notation just uses these brackets here to show that we have a set. Then it shows you what the element variable is. And then it explains what is true about the variable. So in this case, x must be greater than -3 and less than 1. So it's trapped between -3 and 1. And in this next example here, x is between -1 and 2, but it also includes 2. When you have a line under your inequality sign like that, it means it's also could be equal to 2. Here we have x is greater than 5. And here we have x is less than or equal to 2. Now, interval notation comes from the fact that you can graph these on the number line. And so really it's derived from the graph. So let's go ahead and look at the graph for each of these sets, and then we'll talk about the interval notation. So here we have the symbolic representation of this set. And now I'm going to graph it. So I have a number line. This is single variable data, right? We just have one variable x. So it's single variable data. And it ranges between -3 and 1. So here is 0. Here's 1. And then we have -1, -2, -3 on the number line. Now, because x is greater than, or -3 is less than x, it can't be equal to -3. X cannot be equal to -3. So what we're going to do is we're going to show that it starts at -3 but is not equal to -3. So we're going to use an open circle that's not filled in to show that it's not including -3 in the set. Also, 1 is not included. X is strictly less than 1. So 1 is not part of that. So I'm going to use an open circle that's not filled in to show that x is not equal to 1. And then it can be anything in between those two numbers. So I'm going to shade in my graph like that to show that x lies in this shaded area between -3 and 1. Now, this is a graph. So interval notation represents that graph. And to show that the points are open, the circles here are not filled in, we use open parentheses. That's what we call them, open parentheses. And we say -3, and then we put the lower number first, and then we put the greater number second. So in this case, it goes from -3 to 1. -3 is less than 1, and we write it like that. Okay, this is called interval notation. It's a lot easier to write than this. So this is the preferred way of writing. And here is the graph. Let's look at the next example. So here we have x, the set of all x, such that x is between -1 and 2, and it could equal 2. That's what this line here means. It could equal 2. So how do we draw that? All right. Well, we're going from -1. So we have 0, 1, 2, and then we have -1. Okay, there's our number line. And we use an open circle because it's not equal to this. X is strictly greater than -1. It's not equal. So we're going to use an open circle. But when we draw for 2, it could equal 2. So we're going to fill that in to show that x could equal 2. And then we're going to shade in everything in between those 2 points. X could be anything in between. And that's what it means to say that -1 is less than x is less than or equal to 2. So interval notation, now we have a filled in. We want to show that x could equal 2. So we're going to use the open parentheses for -1, but we're going to use the closed brackets for 2 to show that x could equal 2. It's squared off brackets like this. Show that x could equal 2. Now, here we have the set of all x such that x is greater than 5. So to graph that, I'm just going to start here at 0, 1, 2, wait, let me do that differently. X is greater than 5. So let's start with 4, 5, 6, 7, and it goes off to infinity. Now, X is strictly greater than 5, so we're going to use a circle, and then we're going to shade in the number line greater than that 5. So how do we write this in interval notation? Well, we don't include 5, so we use the open curved parentheses, and then notice it goes forever. So we use an infinity symbol to show that X is greater than 5. It goes on forever in the positive direction. And when you're writing infinity in a you always use the rounded parentheses, okay? You can't ever reach infinity, okay? So it's not a number, so that's why we use the rounded parentheses. Finally, X is less than or equal to 2, so we have 0, 1, 2. It could equal 2, so I'm going to use a closed-in point there to represent that, and then it's less than, so it can go into the negative infinity direction. And again, infinity always has a rounded parentheses. Because it could include 2, I'm going to use the square brackets. So this is how interval notation is, how it works.